Equilibrium. When all of the forces act upon an object are balanced, then that object is and said to be at the state of equilibrium. There are different problems of equilibrium. One of it is inclined plane and pulley, and another is tightrope. As you can see in the image, there's an inclined plane and an object on top of it. And there's a pulley which has two objects in each side, and the tightrope, an object in the middle of one rope. You must remember the parts of the triangle, which is one of the sides, which is hypotenuse, the opposite side, and the adjacent side. For sure, we're gonna use formulas. One of it is sine is equal to opposite over hypotenuse. And next is cosine, which is cosine is equal to adjacent over hypotenuse. And we have tangent, which is equal to opposite over adjacent. In other words, to memorize it much more easier, remember SO, CA, TOA. SOH, CAH, and TOH. SOH, sine is equal to opposite over hypotenuse. CA, cosine is equal to adjacent over hypotenuse. And TOA, with tangent, is equal to opposite over adjacent.
Oh, hello everyone. Today we're gonna tackle about inclined planes, pulleys, and tightrope problems. So let's begin.
Okay, hello. We're gonna talk about forces in equilibrium. Object is is moving with a constant velocity is a straight line. Net force or resultant force is zero. Examples of forces in equilibrium. Weight of the book equals normal reaction on the book, which is W to M. Weight of the object equals tension in the string, which is W equals T. Applied force equals friction, which is F. Capital F is equal to F. Force on the tree equals reaction force on the boy equals F equals to R. Sum of all the vertical components of the forces equals 0. Component perpendicular to plane equals reaction force. Sum of all the horizontal components of the forces equals 0. Component parallel to the slope equals friction.
Now we're going to talk about vectors and its magnitude and direction. This is how we solve them.
Hello everyone! Today we're going to talk about adding vectors using the component method. But first, what exactly is a vector? A vector is a quantity that has both magnitude and direction. So let's start with our first example of vector addition. Let's say that vector A has a length of 25 centimeters and is at an angle of 30 degrees. And vector B has a length of 16 centimeters and is at an angle of 45 degrees. Before we start, we must remember the term SO, CA, TOA to be able to know whether we're going to use a cosine or the sine function. We first must draw a diagram. So I have prepared two sketches here presenting both vector A and vector B. Now we must deal with this step by step. First, dealing with vector A. We're going to break down vector A to two components, the x component and the y component. Since the x component is adjacent to the hypotenuse, we can use the cosine function. Now that we have our formula, f cosine theta, we can substitute our values. We get 25 cosine 30, which turns out to be 21.65. And for our y component, since it is opposite to its hypotenuse, we can use the sine function. Having the formula f sine theta, we can substitute our values, getting 25 sine 30, which turns out to be 12.5. Now let's get vector b. For the x component, as we did before, since the x component is adjacent to its hypotenuse, we can use the cosine function. Substituting the values, we get negative 16 cosine 45. It is negative since the x component is in the negative x direction. Now getting negative 11.3. For the y component, since the y component is opposite to its hypotenuse, we get f sine theta. Now getting 16 sine 45 and ending up with 11.3. Now that we have all of our components, we can now add the x components to get its resultant. Sigma fx is equal to ax plus bx. Substituting a plus b for 21.65 plus negative 11.3, ending up with 10.35 or 10.4. And the y components to get its resultant, sigma fy is equal to ay plus by. Substituting it for 12.5 plus 11.3, ending up with 23.8. Now we have to get the magnitude and direction. Starting with the magnitude, we can easily use the Pythagorean theorem for this certain equation. Sigma f is equal to the square root of 10.4 raised to 2 plus 23.8 raised to 2, ending up with 25.97. For the direction, we can use the tangent function, then using the inverse tangent, getting 66.40.